Honors Pre-Calculus Final Exam Review for 2013. This is number 70. It says to write the complex number in trigonometric form, r cosine theta plus I sine theta, with theta in the interval 0 degrees to 360 degrees. So we want to notice that this is what we're doing, is putting into trigonometric form, and we want to notice this interval, 0 degrees to 360 degrees, because it tells us a couple of things. It tells us one thing, that we want our theta to come out in degrees, not radians, so we'll set our calculator in degrees. And it means that, if we need our calculator, and it means, notice how it's closed at the 0 and open at the 360. So that means that if our theta came out to be 360, we would use 0 instead of 360. All right, so our complex number for number 70 is 2 minus 2 square root 3i. So we have two formulas that we use to convert from, this is our a plus bi form, to convert to our polar form. What we're going to do is use these formulas. One is r equals square root a squared plus b squared. The other is theta equals inverse tangent of b over a. And we'll remember that this theta sometimes doesn't come out what it really should be, and we might need to make some kind of adjustment. Also, we want to be aware that the a is 2 and the b is negative 2 square root 3. So the I is not part of the b, but the negative sign is. So neither the a nor the b contain an I. The a and the b are both just real numbers. That means that now, when I plug into r equals a squared plus b squared, I can say that r equals the square root of my a squared is 2 squared plus negative 2 square root 3 squared. So this is equal to the square root of 4. And maybe we have to think about this one a little bit. We know we're squaring something, so it's going to be positive. And then we're going to square the 2 and the square root 3. We can square them separately. So 2 squared is 4, and we're going to have a times, and square root 3 squared, the square and the square root cancel out, so that's 3. So now I have the square root of 4 plus 12, which is 16. And fortunately, the square root of 16 is a nice number. It's just 4. If it were not a nice number, I could leave it in radical form, but I'd have to have simplified radical form. All right, now I'll go about finding the theta. So the theta is inverse tangent of b over a. So that is the inverse tangent of my b, which is negative 2 square root 3, over my a, which is 2. So the 2's reduce out, and then I have inverse tangent of negative square root 3. Now we know what the inverse tangent of negative square root 3 is. We can get it off our calculator, but it would give us a decimal that's rounded, an irrational number. So let's think about the unit circle instead. Since we know the unit circle so well, we know that our tangents are square root 3 over 3, 1, and square root 3. That's in first quadrant. And going down, negative square root 3 over 3, negative 1, and negative square root 3. So these are our circle of tangents. And these are subject to the domain restriction that we use for inverse tangent, which is negative pi over 2 to pi over 2. So that's our domain restriction for inverse tangent. So the actual inverse tangent of negative square root 3 is this angle right here. So I just need to figure out what that angle is. Remember, we want degrees. So since the degrees going up this way go 30, 45, 60, that means that going down this way they're negative 30, negative 45, negative 60. So the inverse tangent is going to return us a negative angle. So if we just strictly do the inverse tangent, theta equals negative 60 degrees. But negative 60 degrees is not a good value for theta, but in any case I need to check to look at my picture graphically to see if this theta equals negative 60 degrees is really the angle I want. So we need to look at this 2 minus 2 square root 3 and try to have an idea of where that is. Well, so the real part is positive 2. Now negative 2 square root 3, I don't know exactly where that is, but it's more than negative 2, so it's down here somewhere. So here's negative 2 square root 3i, and here's 2 as a real number, and here's my complex number. So I need to look at what quadrant I'm in. I'm in the fourth quadrant. I need to look at what is the angle that I got for my inverse tangent. It's negative 60 degrees. but I can't use negative 60 degrees as theta because the theta in polar form is measured from the positive x-axis, so that has to be measured around this way. And this negative 60 measures the wrong direction. Well, it's easy to see how I can get this angle. I can just subtract the 60 from 360, or from 60, I can subtract the 60 from 360. Or I can say, look, I'm going to take that negative 60, and then I'm just going to come back around a full turn to put myself into a coterminal angle. And so what that means is I'm going to take my negative 60 degrees and add a full rotation, which is 360 degrees, and that comes out to be 300 degrees. So my theta, my real theta, see this was a purported theta. My real theta is 300 degrees. So now that I have the r and the theta, I put them into my complex polar form, which is r cosine theta plus I sine theta. And so that r, which is 4, is going to go here, and that theta, which is 300, is going to go for both of these thetas. These two thetas always match. And that means that I'm going to put the 4 here, and I'm going to put cosine of 300 degrees plus I sine, my theta is still 300 degrees. Now that is polar form, also called trigonometric form. So that is how we do number 70, and it should not be surprising that that's also how you will do 71, where the a is 6 and the b is negative 8.